Okay. So what Stu and I are going to be talking about is how do you build an awesome search application using MarkLogic, obviously. And first I'll go through some examples of search applications developed using MarkLogic, and before that a little bit about how search has evolved over the years. I'll do that. And then a slide on what are the needs to build a search application, an awesome search application. By the way, I was told by our product manager I have to use awesome, the word awesome, quite a bit. So I'll use that, and I'm supposed to be animated about it also. So awesome search application. So I'll talk about what goes into building an awesome search application. Stu will double click and deep dive into how do you actually do it through code examples, through design patterns, paradigms. He's going to show you, okay, this is what we talked about. This is how you can do it. David Gorbert talked about envelope pattern in some depth. Stu will even double click even further into it, or another way of doing it. So that's what we'll be doing. Now, how many of you are familiar with this website or what this application does? Raise your hands if you know what this does. Wow, okay, of course Stu knows about it. This is good, otherwise you would have shown your age. This is a project called Archie. What it did was it crawled for FTP sites. This was developed in the early 1990s. It crawled FTP sites, got the names of file names, directory paths, etc., indexed them. Now note, not the content, just the file names, directory path. It indexed them, brought them together in one place so that you can actually search on that. So if you search for some file name here or directory path and hit enter, you'd actually get a list of FTP sites that actually had that content. So that was pretty neat. But what you would see is even in those days, there were some bells and whistles or options control that the site gave to end users to say, okay, if I enter, for example, multiple phrases, do I want to do an and or Boolean search? Some control in terms of how do you want to do the search, and also in terms of how do you want to page. So how do you want to return the results? So that's pretty neat. Even in those times, 1990s, hit the search, enter your search term, hit enter. You can control how search should happen and how the results should be presented. That's nice. And then around the 1995s, we had World Wide Web search. Google, AltaVista, InfoSeek, Yahoo, all these folks came in, crawled the web, World Wide Web for content, index them. Now that's indexing content, and then once you hit your search term and hit enter, you'll get the results link. Again, the concept is similar. You have a search box at the top, you enter your search term, you'll get the results back. But it's evolved into something like this now. This is this is something I looked at last week. It was pretty interesting. I learned a few things even then. So in this case, what's happening is you still have a search box. I enter my search term, I get the results link back. That's remained the same, but it's interesting that you have auto suggest or search suggest. So even as I'm typing in, it's looking ahead and saying perhaps this is what you're typing, and it's actually showing me the results even as it's doing a type ahead. That was pretty interesting that the page was rendered even as I'm doing the typing. That's neat. And then it's also doing spell correction. That says, hey, you've typed in MarkLogic, but probably you meant MarkLogic. Is that what you want? That's neat. And it's also doing, it has a knowledge graph. The interesting about this knowledge graph or graph store is that this information here is culled from various documents. It's not present in one document. So they got all that information, semantically arranged it or linked it together so that they can present this what they call as an info box. This is extremely productive. If I'm looking for MarkLogic, even though I typed it wrong, I'm getting the page and I'm also getting the info box, and if I'm just looking at the phone number, I'm off and running. So pretty neat. So this is what World Wide Web search has arrived today. And then you have consumer search, Amazon, eBay. The concepts are the same. You have a search box, you have the results, but then you have facets. A nice way to categorize, group your results so that you can hone in on your selection much more quickly so that Amazon can make their money quickly. So you got facets. And this is very interesting. They're starting to know about you. They understand who you are, your profile. Gary talked about it. Dave Gorbert talked about it this morning. They understand who you are. so that they can customize your query based on your usage pattern. The interesting there is, let's say I did something 2 days back, I come back again. If there is some new information based on the search that I made 2 days back, they would actually recommend that to me. So they're trying to understand who I am and then making recommendations based on that. We all know this. And here is something else. So they're actually giving me some options in terms of how do I want the search results to be returned. So in terms of sorting, is it by relevance? Is it by price, high to low, low to high, etc.? So what they are doing is giving the end user some control in terms of how to do the search, doing recommendations, and also what order to return, etc. You didn't have much control in terms of what the relevance algorithm or any of those things, but whatever they did is what they did, but you had some control. So that's nice. Now, you've heard about this in the keynote. You will hear about it tomorrow in various sessions, that enterprise search is not like anything else. Enterprise search is just not like World Wide Web search. What you want to do is provide the ability to get a 360-degree view of your content. We talked about getting unstructured data, structured data in one place so that you can actually either form new relationships or take advantage of relationships that already exist. Be able to search and leverage the information, insights present in all of your data, not just structured or unstructured data. That's where the power of enterprise comes in. Wow. Okay. And talked about 360-degree view of everything. So if I have product order details, vendor details in one place, I could say, okay, what were the products that this customer bought? What are the vendors associated with the particular product? I can get a view using all of my data. It's leveraging all of your data to get insights. That's what enterprise search should be about. Now, I didn't see Gary Bloom's, I didn't get a view of Gary Bloom's keynote this morning, so you would see some applications that he showed this morning also here. So this is the Saturday Night Live application, the 40th year anniversary application that we developed for them or jointly with them. As Gary said, this was developed within 4 months, very agile type of project. Now what it does is provide you smart content. So it's content based on who the user is, understanding their profile, and also based on what their peers have done. Recommendations that others may have done will influence the search results that you get. So it was done by enriching and targeting content to specific individuals, constantly tuned recommendations. So some other user saying, hey, I like this particular sketch, that is marked above. There are some points associated with that. Next time when you come in and do a search, if that sketch is part of your results, it may be listed higher. This was done for over 5,500 sketches. How is this done? This was done by taking a sketch and adding tags to it, categorizing them. Could be based on themes, could be based on eras, could be based on personas, could be based on genres if it's politics related, things like that. So that is tagging sketches in documents, but also leveraging semantics technology underneath to form these links to say, I think, Kirsten Wig acted in which sketches, etc., and what were the other folks in those sketches, what did they act on, which era was that part of, things like that. So if I'm looking for cheeseburger, I get cheeseburger, I get John Belushi from John Belushi, I can go to Blues Brothers, to Dan Aykroyd, to Coneheads. So that's being able to navigate that application. That's awesome. That's awesome. That's powerful. Gary, I think towards the end of his keynote talked about this. Or Fairfax County, the applications we've developed for them. This application is a geospatial oriented application where Fairfax County wanted their citizens to have information and services at the tip of their hands. So again, it is geospatial oriented where a citizen comes in and says, I'm interested in moving to this location or interested in knowing crime data in this location. They can search for it and they will get that information. The thing about this is the data variety. We had to get data of different variety, over 500,000 geo-information services data points. Information from police events, service calls, that was all in one place. So on one hand, you had geospatial information, on the other hand, you had structured or unstructured information, police calls, and the variety of sources, over 800 geo-information service layers. As I said, structured and unstructured information. And the interesting thing about the 800 geo-information service layers was lots of them didn't even conform to any particular schema. So they loaded as is, or they either transformed on the way in or transformed after to provide this service for their citizens. This, in the video in Gary Bloom's keynote, there was one of our customers who talked about this, Mitchell One. Again, their problem there was they had auto repair specialists working on a particular model of a car. They didn't have information about it. It could be a new model that came in, but when it comes to that specialist, they may not have information about it. That was their problem. They had all this information in relational database that they could not leverage to present a good search experience or information retrieval experience for their auto repair specialists. They were just keeping their lights on, trying to fit things together instead of leveraging the power of all the data that they had and providing new services. So what they wanted to do here was bring in repair info from over, I think, 350 million repair orders. They had information from other auto repair specialists who are experts. It could be blogs, information like that. And they had information from their online community. They wanted to put all of that information in MarkLogic, structured, unstructured, all of them, and then present a search experience so that if I'm working on a particular car, even though I may not know anything about it, I'm actually getting relevant information. And the other neat thing was they did some spoofing of queries and things like that. So let's say if I'm looking at something and I type in oil fluid, it may not be relevant in the context of the car that I'm working on, but it's able to understand what I'm actually searching for and then turn that search term oil fluid into something that's relevant for that particular automobile that I'm working on. So there was spoofing, there was changing of queries on the fly, etc. So structured, unstructured information, sophisticated search, and delivery on mobile devices, laptops, etc. Oh, that shouldn't have happened. Okay. Now, ignore this for a minute. It shouldn't have happened. We saw some of these examples. What are some of the needs of an awesome search application? What you need is the ability to bring in structured and unstructured data together in one place and support a multi-model approach to it. And with structure, be able to understand the structure and leverage the power of that structure. So you can say, I had this particular element or property, I want to search on that, based on that. Be able to understand the structure, leverage the power of that structure, and also understand various data types, whether it's text for text search purposes, or if you have an integer data type, being able to do range index queries on that. If you have geospatial, we saw Fairfax County, being able to index geospatial information so that you can search on them. So it's not just about structured information or leveraging the structure, it's also understanding the types and enabling the kinds of searches you want based on the type of data that you have. And the query should support these kinds of things. Things like we saw autocomplete with the Google example, spell suggest, they become table stakes, snippets. So once I've done my search, being able to narrow down on particular sections of document. It's not always about returning a document back as a link. It's sometimes putting together information from various documents in the context in which I'm looking for so that the information I'm looking at is relevant for me, so that I don't have to click on a particular link and go get the data I want. That's important. And relevance, being able to tweak it, either as new recommendations come in, being able to say I want to adjust the quality of documents, that is important. Or it could be that I want to boost weights on certain parts of my queries. And Stu is going to double click on some of these. How do you boost weights on certain parts of your queries? What does quality of documents mean? But we saw how you tune your recommendations. Part of that is using the relevant scoring capability and the algorithms you have in MarkLogic. And the platform needs to be transactional, so that if I just ingested a document and I have a search query that matches that document, if that document is not committed, I should see that. But as soon as it's committed, I should be able to see that. So that's the yin and the yang, I call it. It should be transactional, it should be real time. So the platform should afford me those. Configurability, we talked about it, configurability to change weights of documents, be able to weight queries, etc. And the development platform should support the APIs and the needs of you as a developer. Whether it is sometimes it's tying things close to the data, or in some cases it's tying things close to the data comes to security that David Gorbett talked about this morning, where if you have governance policies, I don't want to implement that governance policies in 10 places in my application. I want it to be tied close to the data so that I know, me as an auditor, if I come in and audit, the governance policies are enforced consistently. And my application can just worry about my business logic. And all of this needs to happen in the context in which I'm doing the search, understanding who I am. And it should be able to afford the various presentation layers or support the presentation layers that you saw before. In one case, it was a website. In SNL, Saturday Night Live app, it was a mobile device. In the case of Mitchell one, it was a mobile device. So it's not just restricted to websites and laptops. It's the device of your choice in the context in which you're doing that operation. Stu is going to double click into, go deeper into how do you actually do this? What are some of the patterns? Envelope pattern, how do you boost queries, etc. He's going to show you through code examples, how do you do this? Stu?
Thanks, Ganesh. First thing is, since Ganesh said I'm going to be double clicking on him, as you take that walk around the neighborhood that he suggested, go check out the Contemporary Jewish Museum around the corner, because there's an exhibit on Bill Graham and the Rock and Roll Revolution, which is amazing. So that aside, my turn. Okay, what I'm going to be doing here today is working around the concept of aboutness. Aboutness goes back to the early days of research in information science and cognitive science. The human processes of asking and answering questions rely upon a shared understanding of generalizations. A responsive search application should do the same and should be able to reflect understanding of what each document is about, what the query is really about, what the user's need or intention is, and what responses are appropriate to the user's goals. We're going to be talking about implementing aboutness in MarkLogic. So to do that, we need to know the pieces of aboutness, and especially look at them as implementation items. So we're going to start out with, what is the document about? In MarkLogic, we get the documents as artifacts. They are things. JSON, XML, triples, audio, photographs, video. But our concern in this is going to be, what is the meaning behind those? What is the user actually looking for? So that's what is the query about? They can give us a set of strings. They can give us connectors. But all of that is a proxy for a goal. We need to be able to dig below that stated query and produce a response to that goal. Our search app will need to identify what the query is about by understanding what is asked and what is implied. Next, we need to know about what is the user's activity. Ganesh mentioned that we need to work in the world of a context. That context can be anything from the time of day, a legal jurisdiction perhaps, other information from within the organization, government resources, network information, or information about the people that the person's working with, or the pool of people that they deal with, such as customers or vendors. And finally, we need to be able to produce results that are responsive to the user's needs, not just the query, but to their needs. Modern apps need to be able to support a variety of formats, and in this case, we'll be looking, the typical. Our response formats are going to be just as you're used to with JSON, XML, geospatial, graphic widgets, streaming. But we need to make sure that we are producing those in a way that is useful to the customer. So we'll be talking about implementing aboutness in an awesome search app, there again, awesome, by focusing on these 4 units. The first one being data. We'll talk some about categorization, and we'll talk about the envelope structure. So, start out with some domain knowledge. What are the tools we have available for establishing aboutness? First of all, knowing your data means knowing where it comes from. The knowledge of the company, the corporate culture, is embedded in the language of the data. Large organizations formalize that language in taxonomies. They build maps that reflect ontologies, the connections between those entities. Just as David was illustrating today, the relationships that we build between customers and orders and products. Well, we need something that defines those. He was talking about those predicates. We generalize that and talk about ontologies. And then we also have alternate resources, acronym lists, org charts, RDF repositories that can be used to tie your documents to the user's content. So we're starting off with the assumption that we have a document database, but that we have other information that is important to making sense of that search. So I'm going to start out with a taxonomy. This one is from a public source, the World Bank, and we're just looking at one entry in that taxonomy in the form of an XML version of RDF triple. And there's a set of triples here. And the important thing to look at here is that we have 5 alternate terms for one primary term. The primary term is that top one, non-government bond markets, and below that we have the alternate terms. Alternate terms allows us to narrow down the number of primary terms while still supporting an expansive vocabulary. So that if the user types in corporate bond markets, we know enough to go and look at non-government bond markets because that's our category. Just as Ganesh was mentioning earlier with Mitchell 1, being able to know whether or not an oil pan filter is the same as an oil filter is important for a smart search engine. So we're going to take this a little bit further and talk about categorization. Categorization is the application of metadata to basically provide an overall description for our data collection. Many organizations have made taxonomies that support specific domains available online in RDF formats. Here I've listed a few that are publicly available on the web where you can build your own collections based on those taxonomies. Private taxonomies publicly shared, such as Best Buy's product categorization, encourage the sharing of formats to encourage the building of communities around that language, thus establishing de facto standards in a competitive field. If everybody's using your standard, then people are going to build apps using your standard, which is only going to help you by driving customers towards your vocabulary. So that brings the question, where does Aboutness reside? Where does a document have its meaning? There's some shortcuts. You can always look at the title, make a good guess. You can look at the abstract, make a better guess. You can go check out the glossary. The glossary is usually a pretty good clue if the document has one for seeing what is this document talking about. Law firms, patent researchers, big pharma, other large corporations have research staff who've built their careers upon knowing their domain and knowing basically where that aboutness resides, how to form a very carefully crafted search to address a need. For the rest of us, there's usually a certain amount of trial and error. That you go to an unknown collection, you start putting in queries, and you hope that your queries will address the contents. Of course, you never really know that until you too become a domain expert. Wouldn't it be better to be able to ask, find me documents about my topic? One of the most powerful proxies is a domain-specific categorization. And here's where we refer back, of course, to the Dewey Decimal System as being the grandfather of all of them. Subjects were decided by experts, and then we get to go look on the shelves, and the books on the shelves happen to be in the order that the experts over the years have decided is where those books belong. And of course, the card catalog helps us get there, right? Not anymore. So what we need to do is implement categorization. How do we take a body of text and be that expert for our user to tell them what category this document belongs in? In this case, I'm taking that taxonomy entry from the World Bank public taxonomy and turning a small piece of that into a query. And the query is in serialized XML. You don't need to get into the details of it. Just look at the red and see that non-government and bond are part of a word query, which is actually being supported around by a near query. So we could run queries against the whole collection and categorize with collections based on those results. But that doesn't solve the problem for incoming documents, and it doesn't pick out the most important category found for a given document. So if my document responds to your search for non-government bonds, great. But does that tell us that that document is about non-government bonds, or it simply has a phrase in there somewhere matching non-government bonds? We don't know that. So the technique we'll discuss here can be executed on ingestion and provides a ranked list of categories for document annotation. So here's where we start getting towards that code that was promised. Okay, we're going to use the concept of reverse queries. How many of you have looked at reverse queries for alerts? Some of you? Good. How many of you have looked at them for enrichment? How many non-MarkLogic employees? Thank you. Okay, the idea of a reverse query is to treat a query as a document in the database. And then when a new document comes in, you actually use the body of that document as a set of search terms to say what queries would hit on this what queries would hit on this document if that query was searched upon. Okay? In this case, we are saying if I was running a query on non-government bonds, would it find the document I just ingested? But it works backwards. Since we've saved the query, we're going to do a search and find the query that matches, which is non-government bonds. Okay? So we're going to build a collection of those. And that collection will relate exactly to the taxonomy that I illustrated before. So now we come along with mydoc.xml, and it's a biggie. It's 1 megabyte. And we're going to save it as temp.mydoc.xml. I'm making it temporary because I don't want anybody to be searching on it until I've categorized it. So then the next question is, what do we know about a document? What are the clues that we can use to figure out what Aboutness is? What are the keywords for that document? In this case, we're taking a brute force approach. We're only looking for the We're only looking for key phrases that would describe this document. And since I'm assuming that most of you have been a student at some point in your lives, you know that when you're given a book report that's due tomorrow, you're going to start at the beginning of the book and read as far as you can, and that's hopefully going to be enough, right? So we're going to do that here. We're going to say, let's just grab the first 10%, because a document might be very large, but it may have a lot of spurious references to topics that are not the main things the document is about. In most cases, the document will be described early in the document. There are alternatives. You could go to the abstract, you could go to the title, you could pick out known bodies that would describe your document. But for a brute force approach, just grab the first 10% and subject that to your reverse query. So here's I'm taking my minimized document, which is all in memory, and passing that into a reverse query. So it's going to go look for that list of queries and say, which of you would hit on the top 10% of this current document? Let's say 2 of them hit. The red ones, obviously. We can now, I better read from this one. It doesn't tell us, so it says we've got a hit, but it doesn't tell us where they would appear on the results list. Would they appear at the top or maybe at the bottom of thousands? We don't know which query is the best match, the best category for our document. So which search would, if we have 50 or 100 candidates topics returned, how would we select which ones to apply to our document. If we categorize it as all 50 of them, then categorization is useless. Okay? So, too many topics is just more noise. What we need is a value for the term frequency, which we would get if we had executed the search and seen the document in our results list. So if you run a search, you normally get everything in ranked order, and behind that ranking, there's a score, right? Well, we want to get that score. And so this is a process to capture that, to say, how important is this query to that document? So this is going to be maybe shocking to some of you, I don't know. What we're going to do here is actually run every one of those queries. Let's say we got 50 back. We run 50 queries, but we don't ask for 50 documents. That's really expensive. What we're going to ask for is the log score, the log term frequency score for each of those 50 queries. That gives us a number we can then rank. It comes back out of indexes, so it's very fast. And it's going to give us maybe the top 5 query documents that match our incoming document. So now we have a list of topics. Where do we put that list of topics? If you were awake this morning, you can tell me where we're going to put it because you already know. We're going to put it inside the envelope. So we have now the envelope pattern, which David described this morning, where you have homogenized variant data types. So you can have postal code in one document, zip code in another document. In your metadata section of your envelope, you can have a common term that can be searched upon. The envelope allows you also to remain schema agnostic. You don't have to worry about the incoming format. You just need to worry about how to map it to your canonical data. And this gives us an opportunity to annotate our data. So in this case here, we're going to build another section on the envelope. Just as David had his triples section, we're going to put our categories there. So now we've run reverse queries. We've executed each of those queries against the data and picked out our top 5. And we put those in our category annotation block. And we now have categories that we can search upon that are going to be based upon a common taxonomy and a fixed vocabulary. So basic rules for building envelopes. I'm going to skip over this because we talked about it, or you heard all about it this morning, but it's basically a way of standardizing your ingested documents of multiple types. So next phase, I saw my clocks ticking back there. Query. Query is a dialogue. Whenever you ask a friend a question, you don't expect them to necessarily give you the answer. You expect to start a conversation where by you asking a question, they come back maybe with refinements, such as, I don't know about that field, or which part of this field that I'm an expert in would you like to know more about, or why are you asking me that? So what we need to do is think in terms of a dialogue with our search system. Remember, the whole point of this is to build an awesome search system. So we will establish aboutness through dialogue. And there are basically 4 points of intersection where we have an opportunity to have a dialogue with the user. First one is type ahead. Ganesh showed you an example earlier. This is where you can match your searches, the incoming query against the lexicons, against the vocabulary of your data. In this case, the lexicon may be tied to a specific topic, or it may be the full word lexicon. You can even tie it to the user's search history. If you save the user's search histories and build an index around it, then you can go say, oh, I've seen this search before, and include that in your type ahead. The next point is background search. They've submitted their search, but you don't have to submit the search to the database if you can intercept it and then manipulate it. And this gives you an opportunity for doing things like phrase identification. Are there phrases that match either a standard vocabulary or or pairings that appear within the data? And we'll talk about that in just a second. You can also use it to do object matching and boosting queries, which we'll also talk about. Okay, correction and confirmation is the third part. And that's where it came back with the spell check on Ganesh's slide, did you mean? Okay, you can do several things with that. First, you can do the spell check, but you can also do thesaurus expansion, where you might say, you may be interested in. Or you could do semantic exposition or expansion saying, other topics that are related, where you go and follow the semantic graphs to bring in terms that are applicable to your query. And then finally, drill down. Following up on the search box. When you have a search box on the top of a results page, what does that mean? Well, it can mean one of two things. Either you can enter a new search here, or you can drill down into your existing results list. This is an opportunity for you to do further dialogue, to allow the user to specify more clearly what they are looking for. Then, of course, the facets on the left and constraints on the fly, which I will give an example of. Okay, this is a very brief example, but this is a case where we have a suggestion list. So MarkLogic has built in the API a suggest call so that you can go and say suggest based on this lexicon, given this term, give me other things to look up. Well, that drop-down list does not have to come from one lexicon. It can come from multiple lexicons. By making it part of multiple lexicons, you can actually put labels on it saying, there's a person named Washington, there's also a city named Washington. Which one do you want? So your type ahead drop-down could say person, Washington, city, Washington, and let the user select. That dialog has now just given you a clearer picture of what that user is looking for. So background search. There are several approaches to background finding phrases, but these are just two. One is to take advantage of Sparkle and do matching against the vocabulary. So like I mentioned that taxonomy before, well, you can use Sparkle against that taxonomy and say, oh, what the user just typed matches that, so that you know that that's a phrase. Once you know it's a phrase, you can boost the importance of it and make things that have that phrase matching rank higher than to documents that have just the individual words matching. So yeah, I recommend doing it with a custom constraint, but that's just me. The other opportunity is to do near queries. So you take all the words in the inputted query, and you build near queries around them, and then with those near queries, you can say, if these near queries match my document, then let's raise that document to the top because those words are near each other, so therefore it must be conveying some shared meaning. Okay, some meaning around the phrase. And then final example for this expansion, constraints on the fly. And this is a pretty cool example because here's a case where we have something that looks like facets. These are all the values for one document, right? This is looking up a computer in a system, and we see that it's got a graphics card and a type of memory and so forth. But the facet doesn't exist. But since we've intercepted the document upon rendering, we can turn those all into expanded queries by building constraints around them so that when we now submit the search for a follow-up, in this case, they're clicking on the green for the processor type, we can now limit our search based on something that would normally rely upon a facet. It's now being built from the data instance. Okay, so Aboutness, the context behind the query. Original search engines look for documents. The whole Z3950 protocol was built around the assumption that you would submit a query, you would get a results list back, you would then submit from the results list to go get the documents. Over time, the introduction of Wikipedia, CIA World Factbook, and other sources of record became facts. They became a way of presenting facts instead of documents. so that you could get the information you needed by looking at the first thing that showed up on your results list. And then finally, information. You saw the info box, Google, Bing, everybody's doing them these days, where you build the information on the fly from your scattered information sources. So then the question is, how do you get those scattered information sources into your database? The first thing you can do is, of course, link out. You can build links into your documents, and they can go, when the document is rendered, you go bring that data back. That has a lot of risk to it, and there's only a few times where it's going to be really, really helpful. Maybe for weather reporting or stock tickers, that type of thing. But otherwise, having a more static view of your external data is usually sufficient. So then you could say, well, when I ingested my document, I knew everything about the world as it existed. Therefore, I can embed data. I can go collect facts about the environment, about any of these external resources, and build those into my document and build a nice rich metadata based upon the current state. That obviously has a problem because anytime the world changes, then your documents have to change. So you could copy reference data on a regular schedule into your MarkLogic repository. You just go out and pull in triples lists. You go out and pull in documents that are of common use to you. And then you can make your links internally and make sure that they are kept up to date without having to update your collection. So by building into your additional queries, into your searches, these additional queries or some Sparkle queries, you can now render a document with up-to-date data like the MarkLogic block, having to render that data into your actuals document. So finally, last one with 2 minutes to go. Okay, got it. Results. And this is basically, how do you make sure your results are relevant for your user? First question is, when do you index your metadata? When you're doing, we're often asked, do we need to have indexes or can we use the universal index? And here's the 4 categories where we generally say you have to. If you want the facets, if you want it to be sortable, if you want a field to be sortable, if you want a field to be part of a lexicon dropdown, or if you want a field to be part of a document join, then you really want to think in terms of building separate indexes. Otherwise, the universal index works great, especially for wildcarding or even your search constraints. It's a very powerful tool, and it does honor your elements. It just doesn't have them in sortable order. So the last part is focusing on relevance. How do we make our answer set relevant to our user? And here we're going to talk about boosting, and there's 3 ways of boosting your data. Sorry, boosting your responses. First one is boost the document. On insertion or load of a document, you can set a quality score. When you set that quality score, you are saying relative to other documents of higher or lower quality, the formula for calculating your relevance will be impacted positively or negatively depending upon where you've set that score. So if you've got one document with a score of 10 and another document with a score of 100, all other things being equal, the score of 100 will rise to the top. As you age documents, as you say, I'm dealing with a current news tool. So when it becomes tomorrow, you may say, oh, your relevance we want your relevance ranking to go down a notch because you are now older than today's documents. That type of changing of the quality can be done not on insert or load, but also with a set quality. So you can control your data that way. You can also put on a multiplier saying, the most important thing to me is this quality, and so boost that a lot. Next thing is you can boost the elements. You can say, in the database configuration, I want to set, up here I am adding on a score of 15 to abstract. By adding on that score of 15 to the abstract, I am saying that documents that hit on the term that appears in the abstract on a word query are going to rank higher than those with numbers lower than 15. If you look at the list below, if it shows up in the title, it's way important. If it shows up in the author's list, it's pretty important. Now we're saying if it shows up in the abstract, it's more important than everything else, the other things. So boosting the element is actually going to say that the structure of the document is important to the ranking of the document. Finally, you can boost the term. Here's an example where we have two documents that are pretty much identical, all things being equal. It shows up with the first document being this document discusses companies using MarkLogic first, and this document discusses MarkLogic world second. But we put in a boost query, and a boost query says, return the same answer set you would have otherwise, but rank those things that have the word world higher. So it's a two-part query. The first part is go ahead, do your normal search. The second part is let's give an advantage to these other other terms. And so the boost query allows you to get to the meaning of what the user is asking for. This is, again, part of that dialogue. You are now being responsive to what the user is asking for by making something that they've put in as a boost. And that's where I was saying you could put in those phrases as something to be boosted. Okay, I've rushed through a lot of stuff here, so it's time to wrap it up. So what I've been talking about is aboutness. How do we make our search application understand and responsive to the user's needs? And so that involves what is this document about? What is this query about? The dialogue? What is the user's activity about? How does it fit into their context? And finally, what are their responses about? How do we make the relevance meet the user's goals? And so, tying it all together, awesome apps rely upon an understanding of what the data contains and what the user is after. By intelligently categorizing and formatting your data, understanding your user's intent, you can select what to reveal and a format appropriate for the user's needs. The common thread throughout this process is that you need to look past the details and capture the underlying concepts. Successful apps require less of the customer and anticipate more based upon their knowledge of the data, the domain, and the user. Understanding aboutness will be the key to your success building MarkLogic apps. Thank you.
Thanks, Stu. Was that enough technical details for you?
Yeah, finding that middle ground's hard. The microphone up here.
Just wanted to clarify your definition of, in this discussion, of a query, what the query is about versus context, what the user's activity is about. In query, do you mean what the user's asking as opposed to the X query you're writing?
Oh, yes.
Okay.
Yeah. The query is what the user has typed in at the keyboard. And there again, it's going to be the terms, not their intent. It's up to us to get the implied intent.
Okay, thank you.
Any other questions? All right, thank you.
Thank you.